For question 8, they had given you 3 patterns and they asked you to draw the next design. Okay, I'm not drawing it, but in terms of what you would do, you would have counted, you would have had 1 dark square, 2 dark squares, 3 dark squares. So when you're drawing it, you would have had 4 dark squares, a pale square, and 4 dark squares up. And you would have had a single square in the corner. Okay, next part, it asks you to complete the table. So you would have counted your different patterns and written down the numbers. So for your dark squares, you would have gone 2, 4, 6, 8, 10, and 12. And for the number of white squares, you had 1, 4, 9, 16, 25, and 36. Okay. It asks you to show that the black squares are a linear pattern. If it's a linear, that means that they are increasing by the same amount. In other words, the difference is the same all the time. So you have to show it. So you write down the pattern, you show what you're adding, and you show you get the next thing. So for the few patterns that they've shown you, the difference is always the same. It's always 2. And you've proven that now. Find the total number of black squares in your first 15 designs. So your total number means your sum function, so your SN function. So you'd go to your log tables, you would find your patterns in sequence, and you would write down the SN formula, right? So write down the SN formula in terms of your N. Your N is 15, your A is your first term, which is the case was 2, because you're talking about black squares, and your difference is 2. Plug them all in, you get 240. Part E, it wants you to show that the white square is a quadratic. So for the whites, you write down the pattern that they had. So they had 1, 4, 9, 16, 25, and 36. You write down what the first difference is. So you had 3, 5, 7, 9, and 11. They are all different, so it's not linear. Write down the second differences, and you're getting 2, 2, 2, 2, 2. And then what lots of you are missing out in your original mock is you have to tell me why that means it's quadratic. So you stress, you tell them that the second difference was always the same. So in this case, 2. Right. The next part, it says, show that the number of white squares in any design, Tn is n squared. So I ran out of space on the previous slide, so I'm going to show you here. Your white is a quadratic formula. So your quadratic formula is an squared and bn and c. So it's your typical quadratic formula, but you're writing it down with n's instead of x's. Your a is half your difference. Right, so in your linear equations, your a is your first term, but in your quadratic, your a is half the difference, the second difference. So in this case, our second difference was 2, so half of 2 is 1. Right, your first term would be equal to a bracket 1, b bracket 1, and c. So you're getting an a, a b, and a c. From our first term, we know our first thing had one white tile, so you have 1 equals a and b and c. A is, as we've calculated up here, 1, so we plug it in, so that's basically telling you 1 equals 1 plus b and c, so b is equal to minus c, or c is equal to minus b. Alright, then you write down what t2 would be equal to, so t2 would be equal to a2 squared, b2, and c, so you multiply that out. Sub in what t2 was, so you've got 4, so 4 is equal to 4a and 2b and c. We know that a was equal to 1, so plug that in. So you're getting 4 equals 4 minus 2b minus, you would have had plus a c, right? But in terms of this, I have subbed in minus b instead of our c, because from up here, we know that c is equal to minus b. Why you do that is so that you're only dealing with one term. So you could have subbed in your c's, you could have subbed in your b's, it didn't matter. So when you work that out, in this case, I found out that b was equal to 0. So if b is equal to 0, c is also equal to 0. So when I plug that back into the original formula, Tn is equal to 1n squared plus 0n plus 0. So I'm getting n squared. Okay, so that is showing that the quadratic formula for your whites was equal to your n squared. The next part of the question, it asked you to find the total of squares in the 23rd design of the pattern. So your total of squares is equal to your total of black and your total of white. So we want to know how many blacks were in the 23rd pattern, how many whites were in the 23rd pattern, right? So not the total of them, we just want to know how many were in that pattern. So you are getting T23, for your black, or T, 23 for your white. So our formula for our black, because it is a linear function, is A plus N minus 1D. Your A was your first term, so you've got 2, plus 23 take away 1 gives you 22, times your difference is just 2, so multiply it out and you get 46. For our whites, your whites you got told it was N squared, we calculated that above. So you're having 23 squared, so you're having 529 whites. So your total of squares was equal to 46 plus your 529, which is your 575. Okay, question 9. Sheila earns a gross annual income of 57,500. She pays income tax at a rate of 20% up to standard cutoff. She pays a rate of tax of 40% on the remainder. Calculate her USC and has a table for your USC. So Sheila's gross wage was 57,500. What you do for USC is you take your higher USC value away from your gross. So you're going 57,500, take away 19874. So we have 37,626. You will then take your 12,012 euros away from your 19874 and you get your 7862. So they are your 3 different categories that you pay money on for your USC. So for the first 12,000 you are paying 0.5%. So for the first 12,000 you're multiplying by 0.005. For the next 7,862 you calculated that by subtracting the 2 limits away from each other. You are paying 2%, so you multiply by 0.2. And for your 37,626, which you calculated by taking your gross and the higher one away, you are paying 4.5%, so you're multiplying by 0.45. Okay, so you multiply them all out, you get your 3 answers, you add them up, and you get the grand total of 1,910 euros 47 cents. So that is Sheila's USC. Part B, calculate her tax payable. Her gross wage was 57,500. You take away the standard cutoff, so you're getting 23,000, right? So the 34,500 was at 20%, so you're multiplying it by 0.2, so you're getting 6,900. That's her low tax. The 23,000 is at 40%, so you're multiplying by 0.4, so you're getting 9,200. Add those 2 values of tax together, you are getting the gross tax. So this value here will be the gross tax. From the gross tax, you take away the tax credit, so you are getting 14450. So that is the tax that she pays for the year, right? And then finally, it asks you to calculate her income. So her income was her gross wage, take away her tax, take away her USC. So if we take away her tax, we're taking away 14,450. If we're taking away her USC, we're taking away 1910.45. So Sheila's gross pay, her net pay, the money she takes home, was 41,139.55 for the year. All right, and then finally, it says that Sheila has a credit card, and the credit card charges 4.5% APR on purchases. Show that the monthly equivalent of 4.5 is 0.36 blah de blah de blah. Alright, so your 4.5 is the APR, so your your interest rate as a decimal is 0.045 if you're talking for a year. So if you're doing that for a year, your final for the year would be 1.045, which would be equal to your start, your principal, times your 1 plus your I. Right? In terms of this, you want to change it from yearly to monthly, so you're going 1.045 is equal to 1 bracket 1 plus I, which will be the monthly rate, to the power of 12. So we want to get rid of this power of 12, so how you do that is you get the root of 12 on the far side. So your root 12 of 1.045 will give you 1 plus I. Plug that into your calculator, you get that huge big decimal, and that is equal to 1 plus your I. You then take away the 1, right, and you're just left with I. So I is equal to 0.003674809. But I, we need it as a percentage, so you are multiplying it by 100. So when you multiply it by your 100, you get your 36748, which is what the question wanted. Okay, and finally it says Sheila makes a purchase for €250 on the 1st of March. She makes no payment on her credit card until the 31st of March. How much has she got to pay at the end? All right, so in March, she had borrowed $250 at the start. She didn't pay it back at the end, so she would have had to pay a late fee, and she would have paid interest on the month. April, she didn't pay it back at the end, so she had to pay a late fee, and she'd pay the interest. May, she did pay it back at the end, but she would have had to pay an interest. So what you are calculating is you've got $250, which was the principal, 1 plus your rate of interest, which we had gotten from above, for 3 months, so it's to the power of 3, plus 2 late fees. So when you calculate that all out, you get 26977.